Hello and welcome everyone. Thank you for joining us for our live stream. Today's topic is ACE, the game of cloud CI/CD, unveiling best practices and tools. I'm your host, Peter Van Rysdam, head of marketing here at Cloud Institute. And if you're not familiar with us, we're a training and coaching company that equips IT teams to confidently deliver on IT projects. We offer personalized coaching with cloud experts and hands-on project-based training to help you with your live projects. I'm happy to introduce one of those experts today. Let me bring him in here, Zaki Medina. Zaki is an expert instructor and cloud coach who has coached thousands of aspiring data scientists and engineers. But before I turn it over to Zaki, I want to encourage all of you to ask questions in the comments, and we'll answer them at the end of the presentation. Also, this recording will be available here on LinkedIn and YouTube on the event pages immediately afterwards. If you'd like a copy of the slide deck, just leave a comment in the chat and we'll connect with you and get that over to you as well. So we'll try to keep this to just about 1 hour. So without further ado, I'd like to turn it over to Zaki. Zaki, take it away.
Thank you so much, Peter, for the kind introduction here. I hope everybody's doing well wherever you guys are coming in from today. So my name is Zaki Medina. I will be your guide and Sherpa today as we journey into CI/CD. That has been our theme for much of this month of June, and we're wrapping it up with continuous integration and continuous deployment. So I want to give you guys sort of set the stage of what's to come, right? So in this webinar today, we're going to really journey into this fascinating terrain of CI/CD. We're going to explore some of the facets, applications, and as well as what immense value does CI/CD bring. In fact, it's the de facto way of how software gets deployed now from the cloud. And so we'll delve into why CI/CD is critical for the cloud automation journey. We'll look at its role. We'll look at its pipeline. We'll unpack some of it and also look at an example of using a real world example of using CI/CD. Right? We'll use GitHub Actions and how that powerful tool can help supercharge some of our infrastructure as code, like Terraform deployments and so on. So and the goal here is really not to give you like a tutorial on it, but really to give you a high level overview of how easy and quick is it to automate and speed up your workflow, right? And we'll also cover some best practices around troubleshooting and tactics and things of that nature as well. So, without further ado, as Peter mentioned, my background, I'm a multi-cloud architect. I've actually wore many hats, and cloud. We look after our own cloud environment. I look after a healthcare organization. I'm a CTO. I also look after our DevOps and agile processes, as well as using different clouds. So I use Azure, AWS, GCP, all three on a daily basis here, and doing that multi-cloud orchestration. You would believe it takes a lot of coordination and so on. And we're a very lean team, so ensuring we have all these automation in place. In fact, our goal is to do pervasive automation as we go into it. So as I jump in to the agenda, as I mentioned, we'll really go into sort of the CI/CD side of things. How what are some of the key care abouts that we have, and we'll explore how it, as a tool, how it can transform your software development. One of the things about CI/CD is, even though you may think you've become a maestro, another tool comes in and then changes the game, right? So there's always something coming in. But what I'd like to go in and to really look at is principles today. So today we'll look at principles and not really, we'll approach tools as a sort of a vendor agnostic approach. But in the end, you'll see how infrastructure as a service, or IaaS, CI/CD, and cloud security automation, how they all come together, right? And give you this sort of roadmap and how to navigate for your own cloud automation journey, right? And obviously, how does CI/CD fit into your cloud security strategy, right? So we'll cover a little of that as well. So it's not just that CI/CD makes us fast and efficient, but it also makes us more secure. Because guess what? No manual intervention is required. Everything is automated and it's done well. So less chances of humans, coming in and and creating a fuss. Um, so as we jump in, so the role of CI/CD, if we jump in, so I'm sure many of you have come across the terms. So some of you may, you know, maybe the first time you're hearing about CI/CD, it really stands for continuous integration and continuous deployment, and it is often abbreviated as CI/CD. Now, what makes it such a crucial element in any cloud automation journey, and why we're dedicating a whole webinar to it, is it's really this sort of paradigm that, if we make small and frequent changes, then those are better than doing a big change all over. That's really what it is in its essence. So if you think about how traditionally software has been deployed, meaning, hey, let's release an initial build, and then let's work on the second build or the version 2.0, and we'll release it at one big fail sloop, like giant cutover. Someone pushes the giant lever and we've got new software in there. No, we've done away with that. Instead, every week we're going to progress. We're going to make incremental changes to our main code base, our main software code base, and we're going to do that. And obviously all of this is leveraging the cloud, and cloud is running all of this, and it's done in an automated manner. So this is the paradigm, right? It's making these small frequent changes and integrating them into our main build or main branch, as some of us may call it. And so this leads, what benefit does this give? Well, it does a few things. Number one, it leads to early detection of issues and faster resolutions. So imagine, and you're not deploying a huge code base up front where you could have several issues, and now your whole team is like firefighting all these multiple issues, prioritizing which one is which. Instead, we're doing one or two issues will come up, and those are much easier to handle. And with a lean team that I have in my current day job, it's much easier for us, right, to deploy CI/CD and really look at it. So what it does is it ensures higher quality outputs and much more smoother operations and deployment, right? So, think of it, it's like building a puzzle. Instead of trying to fit all the large chunks at once and running into trouble, we're adding pieces little by little, right? So, the jigsaw puzzle is a perfectly good way. And that way we verify each fits perfectly as before we move on to the next. So in the context of cloud automation, CI/CD is very pivotal. Just to rehash it allows for swift, efficient, reliable updates to our cloud applications and infrastructure, and that, as a result, trickles down to more improved productivity, reduce risk, and even enhance user/customer satisfaction. Right. So, in essence, CI/CD is often seen as a cornerstone of any DevOps operation and a critical enabler of high performance IT. Right. And if today you're not doing it, then I would say, so, and you're probably looking at it, then you've come to the right place. I'm pretty sure by the end of the webinar, we would have convinced you, right? To not just only deploy CI/CD, but to really be a maestro at it and to really ace it, as we say. Um, now, we've had this term infrastructure as code thrown around in our last few webinars and live streams. So it's really just an essential practice of how modern development, happens, where we're enabling developers to manage our infrastructure through code rather than manually configuring it. So we're deploying our infrastructure from a local machine, which we have been doing until now. And guess what? It's no longer sufficient. That's why cloud exists. That's why we have these large scale systems in the cloud. So this is where CI/CD, or continuous integration and continuous deployment, comes into play. It automates this whole deployment process, and it really provides consistent and reliable infrastructure deployment, right? So let's explore some of this. So, we're going to obviously go and use a tool called GitHub Actions down the road. But when we run GitHub Actions, we're going to run our workflows that are going to be triggered by different events. These events could be, hey, someone wants to request the code, or there's a pull request, or someone has created code and wants to add it or make it part of the main code base. Well, guess what? That code commit is what is that workflow going to be triggered by. So we're going to explore some of these use cases, and we're going to run it on, an example is we're going to use Terraform as our example, and we're going to run it in the Azure cloud. That's going to be our example here that we're going to show in a couple of slides here. But what does this do? Well, essentially, it's going to help us cover some of the best practices, like how do we manage secrets and variables? How do we get to monitor and maintain our deployment once it runs? And then, as we leverage CI/CD in the cloud for our infrastructure as a service, leveraging GitHub Actions, guess what? We're going to find so many areas in which we're going to find value add. And so we'll cover some of this. So this is just kind of setting the stage on how we go about and deploy this. So before I jump in, I wanted to do sort of a little intro. I know we've done an intro in our last slides, but some folks that are new joining us today thought it'd be best to just introduce some of the tools. So the first step is Terraform. So Terraform is an open source infrastructure as code, or IaaS software tool. It's predominantly the big one. It's the oldest, one of the oldest ones, and the most prevalent one. And it allows us to safely and predictably manage infrastructure at scale. It has been widely adopted by organizations and IT professionals, most of which are developers, right, over the years, and is recognized as one of the most influential tools in this space. It's considered cloud agnostic. So, and infrastructure as a code, when you look at it, it follows the same principles. It actually set up sort of the whole IaaS ecosystem of tools that we see today. And people can make the case that there are better tools than Terraform, but Terraform has been around a lot. And so we'll talk a bit about that as well. So, one of the things it does really well is the concept of modularity and automation, right? So obviously, as an automation tool, it's very powerful. It facilitates infrastructure management in any of our cloud environments, whether it be AWS, GCP, or even Azure, right? Or even a combination of those. So Terraform keeps and manages sort of this internal state of our managed infrastructure, and basically can help create plans, track changes, enable safe modifications in these live environments. And that's one of the reasons why Terraform is hugely popular and why it's been successful. It's got this very nice, intuitive, easy to understand workflow. And in fact, the core Terraform workflow really consists of three stages. First, we generate the infrastructure as a code configuration file, right? This is representing our desired state, right? So I'll come back to the word state later on, but just keep in mind that's what we mean. So first, we generate a config file around what we want, what is our desired state or future state of what we want our infrastructure to be. Second, we check the output of that generated plan, because it's a plan, right? And then based on our information that we may have, some of this we take this information and we edit it, right? And you call these edited manifests, right? So just won't worry about the jargon here, but just giving you a sort of a quick overview. And then finally, once we reviewed the changes, we want to apply the plan to provision the infrastructure that we want. So, so just to give you an idea, we first plan, and then we review or check, and then second we apply. So those are the big ones, right? From a Terraform perspective, when you think about this. And I also want to give sort of an overview of GitHub Actions. It is the modern CI/CD tool. It's what I used on a daily basis, my team and I. It's the beauty about GitHub Actions is, yes, it does share a name, and for the right reasons, with GitHub, which is one of the largest, open source or paid private code repositories out there. And the beauty of it is it's actually a CI/CD tool that natively integrates onto GitHub, right? So it's very easily possible to automate our build, test, deploy, and other custom workflows on GitHub without needing any external tools. I know in the past we did need external tools, but GitHub decided, you know what, we want to improve the developer experience a bit more. We're going to provide GitHub Actions. Now, some of you may be using other tools like Jenkins and so on. You still can, and you can still use your favorite tools, and there's nothing wrong with that. It's just with GitHub Actions, it's just one less ecosystem tool to worry about, right? Everything is there, and the price point is very fair as well. So, one of the things we like about GitHub is it's very easy and seamless way to automate almost every software workflow right now. So in GitHub, we store our code, our software in repos, right? And so it helps us, we're able to sort of take out the necessary infrastructure pieces and sort of abstract them, and then leverage and automate some of the workflows that we have within our software. So now when you look at this tools architecture, right, it really depends on events. Events is what really triggers all the actions that come out. And then it sort of, you generate these custom user-defined workflows. And that's basically how it works. So, and GitHub Actions has sort of evolved over time. It's very different from what it was when I started using it. Today, many would consider it a mature tool in the CI/CD ecosystem. It has many customization options. One thing I really love about it, it has the workflow engine, right? It's very robust. And if since my team is already using it, and then many others so much, it just makes life easier, right? We have so many options for running different processes, or we can bring our own VMs. We can support other workflows across different environments and operating systems, versions, and programming languages. What's interesting is that in my e-commerce healthcare app, I have, parts that are HIPAA compliant, like I have different governance models for each of them. And so I can actually create the process one time and apply it in both of these, and then it will check the boxes from a compliance perspective on these multiple compliance regimes. So that's really, really powerful for us, and a great godsend. Another great benefit of GitHub Actions is obviously the power of GitHub, right? Which is itself an open source community. So, as we're creating our workflows, we always find there's people sharing their learnings, their best practices, their tips. So that is something we can easily depend on. Now, some of the things that come up around as we dive into GitHub, right? We know it's an automation platform that allows developers to sort of create the workflows to automate the different software development tasks, which in our case means sort of managing and deploying our infrastructure as a code workloads. So now, and GitHub Actions hasn't been around a long time. You could somewhat argue it was just mid 2019. So when it was launched, I remember, the initial release, you could only have a select number of developers that would create and share the actions that were needed, and these actions would then be used to automate some of the repetitive tasks in our development workflow. And obviously there were other automation platforms. I mentioned Jenkins, there's Travis CI, there's Circle CI, all of them great tools. So, whatever your developers, your team is familiar with, definitely use those. Now, the thing with these kinds of tools is they're all event driven, right? So that's the event driven paradigm, meaning we execute a series of commands after a certain event has occurred. So you can now create multiple workflows and multiple jobs in GitHub Actions. And then we see from our diagram here, each and every job we create is sort of running on a runner, right? Which is basically a process which separates virtual machines inside the GitHub server, right? So just to give you a quick overview here, events, when we refer to events, what do we mean? We mean these are the things that trigger the workflows and GitHub Actions, and they support many event types. For instance, either we're pushing to our repository, we're doing pull requests, scheduled events, manual triggers, anything that an initiator triggers the execution of a GitHub action workflow. The event is called sort of an internal GitHub event, like a push or a release or a fork or an issue or a pull request. So we also have scheduled events, right? These are triggered by a specific time, like maybe a background or a cron job, or maybe it's just an arbitrary external event, right? It's triggered by a webhook call to a good GitHub API, right? That's an example. Then we have our workflows. Now, these workflows, think of workflow as, it's a workflow. It's a series of tasks that are automated using GitHub Actions. And workflows are kind of defined in YAML, right? YAML files, these are just regular markdown text files where the indentation is really important. And then they're stored in sort of a repository. Now, workflows can be triggered by various events, such as you're pushing code to the repository, or whether we're creating a pull request, or even scheduling a job. So basically, workflows are composed of jobs that can be started by an event or by scheduling them to run at a specific time. So workflows exist, they assist in sort of in helping us build and test, release, or even deploy our software project to GitHub, right? And then obviously the individual units of the work are performed by what are called jobs, right? So jobs are these individual units of work. They're performed within a workflow. A workflow can have multiple jobs, each running on a different platform or environment. And then jobs can also be run in parallel or sequentially, depending on the workflow requirements. An example of that Could be, let's say I have a set of steps that are run inside the same virtual machine or inside a container. So by default, they're all executed in parallel. In other words, they don't wait for the previous job to be finished. So this is great because now we can configure the jobs to run one after the other or as needed or together, right? So that's the beauty of it. Then we have steps. Now, as we talked about the job, there are individual tasks that make up a job, right? Like, hey, you have a job, I have a job. We're all doing different tasks. Those are called steps or actions. And so these are the individual tasks that make up a job. Each step is either a shell command, a script, or an action. And these actions are pre-built units of work that can be used to automate everyday deployment or development tasks, such as whether we're building or testing code, we're deploying applications, we're sending notifications. Those are all examples of steps or actions. And we have runners. As I mentioned, runners is really just a virtual machine that has a job, right? Just think of it as a busy virtual machine. Hey, I'm a busy virtual machine. I got to run somewhere, so I'm a runner, right? So that's the term that's used. A runner is responsible for looking after the available jobs. It executes each job at a time. After the job is finished running, the runner reports the progress and logs the job to GitHub. So runners are sort of hosted by GitHub, and they consist of either Ubuntu, Linux, Windows, or even Mac OS, right? They're running on a number of these types of operating systems. So as I said, GitHub Actions, very powerful, automation platform. It allows developers to automate many tasks in their development workflow. And with its sort of flexible, customizable workflow, I would say there's a huge support for various events and pre-built actions. It's become our de facto essential tool in our DevOps environment, right? So, and I feel it is gaining on a few other of the CI/CD automation tools out there, and so on. So let's jump in and look at sort of the next steps of this. What we did was, just to preface this before everyone, is, with this short webinar, we're not able to dive really deep in and do a live demo of how all of this works. If you're interested in a live tutorial of this, from soup to nuts, do paste the link in the chat here. Maybe it's something we consider in the future, but just for timing purposes, we've just taken slivers of the code at certain areas just to show you the larger context. Really, the goal here is to give an overview of the entire process. Obviously, we can't fit everything in the time frame of our webinar today. So, just to be cognizant of that. So, yes, I won't leave. There are a few little minor steps missing from all of this, but in all, I will go through all of it in its entirety, and feel free to ask questions. So that will be helpful for us. So as I mentioned, we're leveraging sort of CI/CD in the cloud. As we're leveraging Terraform, every time we run Terraform, there's a file called terraform.tfstate. Now this is either created or updated or read. It's basically a JSON formatted file. It's containing sort of information about resources that's created or modified by Terraform. It includes things like IDs, IP addresses, and other metadata associated with each of the resource that we manage with Terraform. Now, Terraform does a really great job because it actually uses this file to keep track of our current state of our infrastructure, and it uses that to determine, hey, what changes must be made when we need to modify our infrastructure code. So this state file is absolutely critical for the correct operation of Terraform. It ensures that Terraform always can accurately determine what changes needs to be made in the infrastructure. So, whenever we run the terraform/apply command, so remember, I talked about Terraform and how, apply is the last step. Without the state file, apply won't work. Terraform won't be able to determine what changes were made to the infrastructure. And guess what? This could result in errors or unexpected behaviors. And we go back to the cave days, right? So, and this could result in the termination or redeployment of the resource. So it's very important for us to treat the Terraform state file as, sensitive information, right? So it contains, again, many details about our infrastructure resources, A lot of this could be potentially sensitive information like passwords. So if you've used Terraform to generate them, then yeah, that makes a lot of sense. So again, we want to make sure state file is secured and so on. Okay, so now what? Once we've got our state file, what do we do with it? Guess what? So, the way GitHub Actions is designed, GitHub Actions will bring in the necessary compute resources for a very short period of time to execute this workflow for us. And you can call this a familial compute because there's no fixed storage. So once the workflow has been complete, the compute resource is terminated and everything is lost. So now to support this, Terraform allows us to use what are called backends. So backends are used to store our state files. As you may have guessed, there's a default storage option or local storage that could be used, which will store the file in the same folder as the Terraform code you're executing. Or we can use an external blob storage, like for instance, in AWS, it's S3 or simple storage service, or in Azure, which is the example we'll use an Azure storage account, which has a blob storage in it, So, that's what we're showing here. We have a container name, parameter. In this case, it's the Azure storage account. That's the blob container. And, if you're thinking about an Azure storage account, as a file system, then this would be the folder name, and the key is the name of the file. So the configuration in S3 would also be very similar, right? We would have something, although I don't have it here, but you'd have something like a backend would be termed S3. You'd have a bucket, right? A bucket name, and you'd have the key, the same name, and then the region that's associated with it, right? So that's sort of what we have. Okay, so jumping in, now we're going to leverage, the example we used was Azure, and obviously this can apply to AWS. If you're interested to see a version of this for AWS, please post in the notes so Peter and I can take it back to the team. So a lot of this code is actually from sort of Azure command line interface or CLI. So, you could pretty much, instead of, a lot of people think about the cloud portal as, we're just using our mouse to move things around, click, next, but everything can be done in code. And a lot of times people prefer it because it removes errors and things, because it's easy to fat finger something and forget about it and not come back to it. Whereas with the code, we can track it. So, the first step is we obviously need to look at credentials, right? What credentials to use and grant access to our Azure subscription. So again, one of the things is we've assumed you have an Azure subscription. You assume you've created all of those, app IDs, password, tenant IDs, and so on. And now we can really jump into sort of, create our, our GitHub repository. So the first step is to create sort of a GitHub repo. We're just calling it, we're, for sake of Git, we're just calling it Terraform-GitHub. And so the first step is to add the secrets and variables. So we go to our repo, we click on settings, we go on the settings open. You should see secrets and variables on the left-hand side. We click it, we expand it. There's a sub menu with actions, code spaces, and Dependabot listed. We'll ignore Dependabot for now, but you would have guessed it. We need to click on actions first. So this is going to present us a few things. And then once we click on it, on the actions, we're going to basically it'll ask us to put a new repository secret, right? You guys can see new repository secret on the left here. It's already highlighted. And then guess what? That's where we enter our secret details, right? And those are the tables on the far right, where you can basically put the name as it's written in the table, or as it's defined in the GitHub action workflow code. So this will become our GitHub action workflow code, and that we're going to reference it. And I'm not going to go through it in detail, but it has things like app ID, client secret, subscription ID, tenant ID, right? Those are all the things that the four things that are needed. And then at the bottom, we have our variables, right? What is the name of the resource group that will create or host the storage account that we'll use for the Terraform state file, right? what is the region in which our Azure compute is, right? And then what's the backend Azure storage account name that we want to use, right? Again, this account name has to be unique across all of Azure, otherwise Azure will prompt you to change it. And then obviously within that storage account, what's the container name where the files will be stored, right? We're calling it TFS state. And then the name of the Terraform state file itself, for instance, is GAC .tf state, right? As an example. So this sort of, this is where we have everything that we need now. We've got our secret and variables covered. We're in GitHub repository. Now let's look at sort of the workflow in itself. As I mentioned, YAML, right? GitHub action workflows use a YAML. YAML, has many languages. It's, sometimes it's colloquially called yet another markup language, right? Depending on who you talk to. So what it basically is this human readable data serialization format. It uses indentation, as you can see, to convey structure. And so indentation is really key. It's very popular for storing configuration files, doing data exchange, any kind of applications that require simple data representation. So first we have some, basic configuration here. We use name to name the workflow and define the on, right? The on parameter here to specify what action the workflow should trigger. And as we can see, the workflow will be triggered as defined in the on section of the YAML file, right? And then there's a push or pull request on the main branch. Now that we have defined when the workflow will be triggered, we can now define sort of the 3 jobs that go into making up this workflow, right? So starting with a job that checks the presence of the storage account, we're going to use for the backend Terraform state file. And if it's there, if it's not there, guess what? We'll just create one, right? So that's not a problem. I would say the big thing hang up here, everyone makes this mistake 100 times, is indentation. It may sound very simple and trivial, but indentation is very important to the structure of YAML file. Yes, spacing matters. And while working through any kind of structure, you want to make sure that the indentations are made in a way that makes it very readable, user readable, right? Again, there's enough, there's definitely some readmes within GitHub itself that will give us guidance on how to do the correct format, indentation, and title, and so on. But this is sort of the high level. Okay, so next up, we sort of define our jobs, right? And we've now got our basic configuration, right? Here, we're just giving the job an internal reference. For instance, we're saying, hey, check storage account, right? And now we're just telling it to run on the latest version of Ubuntu, in this case, and use Bash as your default shell scripting language, right? So that's basically it. Now, the check storage account is actually made up of 2 steps, right? Step 1 being, the check storage account job is made up of 2 steps. Step 1 being, hey, we want to use the Azure -login at v1 task to log into our Azure account using the secrets we defined, because you got to log in. And then these are referred to in this, you have this $sign and a secret start arm. ARM stands for Azure Resource Manager. It's the arm that moves Azure. And is asking for the client ID, right? Okay, so once we provided this, the next step is we've added the secret. We got to use the variables we added into GitHub, right? And now it's going to check for the presence of Azure. Will check for the presence of a storage account. If it's there, if it's not there, it'll be created. If it's there, guess what? The resources already exist. Then the task will progress to sort of the next step, right? And in the next step, let's say, we need to do this once. Once we're logged in to Azure, we don't need to really authenticate it again. So we simply run a bunch of commands that you can run, like Azure group create to, check for the presence, or if you create one, or Azure storage account create to see if your storage account is created, or Azure storage container create if your container is created, right? Just in case you have that. Again, those are troubleshooting steps, and so on. So now that we have a storage account, guess what? We're back in place for the Terraform. backend file. So Terraform now, we have the state file storage. It's our backend file. We're going to proceed with the next job where we run the sort of Terraform underscore plan command. Now, what this Terraform underscore plan command, this is the first step of Terraform, is we plan, right? We plan our infrastructure, right? So you want to store the output of this plan into a workflow run. And so that's what we're doing here. So as per the last job, we're just going to set up some basic configuration here, and we add in things like job name and reference, which operating system to use, and then some additional bits of information. And then that's it. As you can see, we're set up now. We have some environmental variables containing the credentials that we need to log into Azure. Now, why are we doing that again? Well, didn't we already authenticate in our last job? Well, guess what? The reason is that once the last job is finished, the compute resource running the job is terminated, right? Because it's ephemeral compute. And then when this job is started, a new resources was spun up. That means everything from the last job was lost. So it's not a big deal. You can run it again and again, right? It's just consuming quick compute. So, but it's just to be, just for us to be cognizant of. So now that we've defined sort of the basics of our Terraform plan job, we can now work through sort of the next steps, right? And in these next steps, we have this simple step where where a simple step that checks out the repository from which we are running the action. The repository contains the Terraform that we will execute during the workflow. Now we have the code we need to install Terraform. To do this, we use sort of, the setup Terraform at v2 task, right, that we have created. And so far, so good, right? As per what we're doing, we're running Terraform. And now we're ready to go in sort of the next step where, as we're running our Terraform, we now need to jump into, creating, a copy of our TF plan, our workflow execution plan, right? So here are all the tasks and jobs that we need. We can simply download this file and use it without committing to the code repo, but, it's fine. The next step is what we have here is really to, is really just to look at the file, right? So we have TF plan string. So one of the advantages, just a quick side note, of using a system like GitHub Actions is you can publish artifacts and also publish other outputs. In this case, what we're doing is we're taking the list of changes logged within the plan file and formatting it as a workflow summary. So this is great. We have our summary as well, and we're publishing it. And then the next final task, and obviously we use this summary, I'm going back, just to make sure that everything is in place where it needs to be. There's nothing that we fat-fingered. The next and final task within the job is to take the summary that we have generated and then publish it back to GitHub, right? So here it says publish Terraform plan to task summary. So that's what we have. We're publishing it. And now all that is left is really to run sort of the Terraform -apply command, the magic command, the moneymaker command, right? This is the last job of our workflow, and it shares many of the steps from the previous job. However, I just wanted to highlight some of the configs here. Yes, we do have some if and need statements here. The if statement verifies that we're 100% working with the correct branch. That's how GitHub sorts its code. And then the need statement ensures that the Terraform plan job has been successfully executed, meaning that we will have the Terraform plan file, right? So this is it. The first three steps are the ones that we've already covered. We checked the code, set up Terraform, and ran Terraform in it. Next, we just need to download the Terraform plan file, right? So we download the Terraform plan file, and we can, with the plan file downloaded, guess what? We can now perform sort of another task within the workflow, which is to deploy the changes within our Terraform apply, right? So again, any detailed changes within the plan file, we run that. That's the second step where you run Terraform apply, and then this is very simple. You run it. We even put a auto approve flag which means that if we don't, then Terraform will quite happily sit there for an hour waiting for someone to type yes, which will never happen as this is not an interactive terminal. So, we want to make sure we put that flag in. Oh man, that would be a horrible exam question, right? So we are then telling it to basically load. The next step is once we've done this, we're basically telling Terraform, hey, load in the file called tfplan, and then run the Terraform plan command, and then the changes will be applied. Now, what happens to our Terraform code once this is done? Well, guess what? In the back end, in the Azure backend, our main TF file will change. It'll give us sort of an increment of, here's the new version. We've made a change. And if we really want, we can go into GitHub here and take a look at the workflow YAML file. And there's a place in a folder called GitHub/workflows, sort of at the top level of our repository. And there's a file, it's called action.yaml, right? So, this is really, again, in this file, the folder name usually has a dot added to it, but we've removed it for our sake here. So, so the GitHub action is not registered, right? So when you copy your repo, always make sure that you rename your GitHub folder to .github. Otherwise, the action won't be registered and the GitHub will not run, right? There are these small idiosyncrasies, that come up, and it's just, when I was a newbie, I ran into a lot of these. So anyway, so let's say this is the first time we run, the first time we check in the action.yaml file, it's going to create an action and a run, and this can then be confirmed by the dot next to the commit ID, and then which in this example is referenced, right? It's referenced as sort of B4900E8. You can see it at the top. It says 1 minute ago. Yeah, so that's where it is. So, now everything should run as expected, right? Don't expect anything too different. And as we're running this, we can click on the Actions tab actually at the top of the repo, and this will show us something like the following that's here, right? So clicking on this, it'll take us, if we want to even view a summary of it, we can even go look up a summary. Okay, there you go. It wasn't moving. So here, when we click on the clicking on the workflow run, it's going to take us to the execution summary page for this. So it's looking like the following. And as you can see, we have 3 jobs listed and the artifacts and sort of the custom summary as well. If we want to double click into this summary, we'll see what we published from the Terraform plan job. We can click expand and it'll show us this entire output of our Terraform plan command, right here. It's showing it all in a nice viewable way. Again, we can even click on any of the jobs if we want to, and it will show us an output of each of the tasks if we need to, right? So as an example here, right? So here, click on some of the job names, and then it's showing us the output of each of the tasks underneath it. Again, I always recommend to folks if the first time you're doing this, always click around, review precisely what GitHub action workflow executed. It gives you a very pretty detailed information. And I guess this is new to if some of you that have seen this, but if you check around the Azure portal, you'll see a resource group, storage account, and container where there should be a single file called ghack.tfstate, right? So you'll see that file also be there as an example. So so here we're checking our Terraform state file in our Azure portal here. You'll see that there. So this is how we know. This sort of concludes our GitHub Actions, right, to run Terraform. Now, before we jump in, right, obviously there are questions. Can you do this with other tools? I said, yeah, you definitely do it with Ansible, right? That's the other one, very popular tool that's used. There's a few other tools. I use Pulumi, which is basically like Terraform, except you can use Python. And then there's others like Amazon AWS has its one called Bicep. I think Azure has something called Bicep, and then there's CloudFormation from AWS, right? So sometimes I get confused which name is which. So this is sort of the high-level overview. We went and we looked at our workflow with GitHub Actions leveraging Terraform. Now, from a security perspective, is very important. Talk about security, as I mentioned. The TF state file, very important, has passwords, credentials, TF state. When we've worked with tools like Terraform or even Ansible and others, we're basically adding our secrets to our GitHub repository, right? If you think about it, I'm taking my password and secrets, storing them in the cloud. Oh boy. So all the sensitive information, yes, it should be stored in secrets. It can be stored in outside sources, and there are tools, specialized tools and resources for that. For instance, all three cloud vendors have their own tool. Like you have Azure Key Vault, AWS Secrets Manager, of GCP Secret Manager, and you can even use HashiCorp, which is the company that runs sort of Terraform, right? They have one thing called Vault as well, so you can run it in anywhere. Or you can use the centralized cloud key store, key management store as a place. So this is sort of the advantage of these secrets, right? So these secrets will remain hidden, but then the code will also be able to be consumed by them. So that's great. So you can share it with people that you want to, but no one gets to see what's inside of it, right? So that's great. Now, one thing to note, anyone who has been granted write access to the repo will also be able to consume them, though they won't be able to view the content. So please be very careful when you're granting access to your infrastructure as a code CI/CD pipeline, as they will have a high level of access to your cloud resource via workflows. So, please ensure you only grant access to trusted members of your teams. I would say that's the number one thing about cloud. How do people get in the cloud? You hear about its authorization and authentication. It's AA. It's improper credential management, right? And so, the joke is it's layer 8. So, and it's not a joke because it has it has real implications. So far we've seen some of the code samples, and we've done an example of an infrastructure as a code. Now, let's jump in and look at what are some of the IAC best practices, right? So there's some common threads that we've already touched upon, right? So version control. Now, version control is a great example, right? So, make sure that you use a version control that's very familiar, that with your team. An example would be Git, right? Git is one, or maybe there are other versions you're using like Mercurial, Subversion, or Azure DevOps Server. This used to be known as Team Foundation Server, TFS. It's been a long time, and so on. So now, obviously use the version control of that all your other projects use. So it's very important you take steps to define and deploy your infrastructure in and as code. That means you have to experience it with version control and access to tools, processes, and procedures to maintain this version control, right? So you're basically, employing version control to track changes, enable collaboration, and do easy rollback of previous versions if needed, right? So hey, something worked in the past, but this current version is not working. Let's roll back and then come back to it later. Yeah. And obviously going hand in hand with this is documentation, right? So we want to make sure we approach documentation in several ways. It doesn't matter how we do it, as long as you do it. So this is interesting. My personal approach to documenting IAC deployments is to try to keep as much of the documentation within the code as possible, possibly using it, in comments, and that makes sure that label everything. Hey, this section, and then you do a comment like in there, right? And make sure that the section, task, functions, or variables are clearly named and as descriptive as possible. The joke here in software development is 50% of it is naming, and it's true. So you want to make sure you keep all of these, all of these within the tool you're using. Now, depending on the complexity of the deployment, I often will summarize the code. I'll just attach a README file and commit that to a version control. And the reason we do this is it's easy to keep track of what's going on while you're working on the project. Let's say someone else shows up, new person comes in, and or maybe you've left and you're revisiting it after a few months. Guess what? You've been away. You want to get a bit of your bearings. It takes time, right? So having that documentation in place is really nice from a best practice perspective. Then you have code reviews, right? I regularly recommend code reviews to maintain code quality, insurance compliance with best practices, and share knowledge among team members. There's a percentage of every developer in our team that they contribute to code reviews, and they also look at how to make the code better, right? And those become sources of future work for us and change requests. So then modularity, right? So when you write your infrastructure code, do it in smaller reusable modules. And why we say that is because you want to just write it once, right? Um, you want to write the code once. It promotes huge reusability and maintainability and better organization of your code base, right? And then obviously CI/CD, right? We've discussed that. Even for development purposes, your code and source control should ideally be using CI/CD, even if it's test, if it's dev, even if it's local machine, still leverage CI/CD, right? So that way you get into the habit and you're not making any mistakes. It becomes second nature. And then testing. So we're testing, again, in a perfect world, we should implement automated testing for infrastructure code to validate its correctness. We want to identify issues early and so on. And then monitoring and logging, right? You want to track sort of the execution and detect issues. This is going to allow us to troubleshoot problems promptly, right? So one thing in our CI/CD pipelines is it already keeps a log of everything that's happening during the execution. So in like Terraform's case, we're generated and we've attached a snapshot of the plan file. Now, this level of information can be very valuable when trying to figure out what would happen if something unexpected happened, right? Then we have sort of the principle of least privilege, right? So basically limit access to resources and creation by granting a minimum necessary permissions for our infrastructure code execution to interact with the components they are working with, right? So depending on your target infrastructure, this may only sometimes be possible, right? Then there's the other things like immutable infrastructure. Rather than updating your existing infrastructure and create new infrastructure, replace old one, you're basically just repurposing it again, because you'll use the config file again and again. And what this does is it prevents errors from configuration drift. It forces deployments to be more predictable. Again, it all depends on your application, right? So it may only be practical for you to implement this approach. But still, the more infrastructure components you make immutable or repurposable, the better it is to scale and back down. And then finally, we have secure by design. Again, as I mentioned, we're not doing it manually every time. We're writing it once, incorporating all the best security practices and tools from the beginning, like encryption, identity management, network segmentation. And guess what? This just makes our code better, easier, more modular, and so on. So those are some of the things. I'm sure there's a few others I may have missed, but as we go through this, you'll see. From a troubleshooting perspective, I would say there's just a few really big ones, big gotchas, when we've done this. Um, it's basically, we want to avoid hard coding sensitive information. We're using secret management tools like Azure Key Vault, HashiCorp Vault, or AWS's secret manager to store some of this. So it doesn't go without saying you shouldn't hard code sensitive information such as passwords or secrets. You should just be leveraging those secret repositories or key management services and so on. And so on. I've often seen people like, hey, our SSL certificate expired, and guess what? We're now rushing all our resources that reference it to get it updated. Guess what? Everything is in our secret store. That means we just have to update the certificate, then all the resources that use the certificate are automatically updated. So that's the advantage of using it, right? Next up is keep your dependencies up to date, right? So we do a dependency check once a week, once in the midweek and the end of the week. So we make sure that we avoid any security vulnerabilities or compatibility issues, right? And then the next one is don't overcomplicate your infrastructure code. Make sure we have clean, well-organized code base where you're following a proper directory structure, removing obsolete code, and so on, right? So, and then we don't ignore any. Last but not least, we don't ignore any error or warning messages, right? We address them promptly and we communicate that to our team and so on. So this is sort of, it's kind of it's kind of common sense, but sometimes I feel you do have to call it out so that everybody's on the same page. And so that's basically it. That's our live stream for today. I just want to give you a quick recap. We looked at how CI/CD works in the cloud. We looked at sort of infrastructure as a service. We looked at an example using GitHub Actions and Terraform together. How we took we took our plan, our Terraform plan, and TF state, and we checked it, and then we applied it in GitHub, and how we checked it again, and we made sure it was residing within our Azure storage account. And then we talked about some of the nuances within it. We got familiarized with the workflow process, how indentation is important, how the dot in GitHub is important. We looked at some general security best practices. Always use a key management store, centralized key management store. Look at some of the best practices and troubleshooting tips. So all of this together, hopefully will give you guys more than enough to go at this with whatever cloud automation tool you go at. And so with that, I pass it off to Peter. Peter, how's it looking? Any great questions coming up from the folks?
Yeah, for sure. We've got some good questions here. So let's take a look. Our first one is from Leah. It says, do you have any tips for managing version control when working with multiple developers?
Yeah, so each developer will basically, this is actually within Azure. I'll give you an example. Within Azure, we would simply create read or write, or read-only access for the type of developers. So not all developers should get the same access. Maybe there are developers that just do code review. There are testers, right? And then there are developers that actually make an input into that. So you divide them into two groups, and then you give the right permissions accordingly, right? So that way we have we've created some kind of structure with that. So hopefully that helps.
All right. Let's see. Our next one here says, what metrics should I keep an eye on to optimize my DevOps processes? That's from Ari.
Awesome. So DevOps is a lot of things. The various metrics to consider in DevOps. You have things like lead time, right? The amount of time taken from the moment code is checked into the version control to the point it's live in production. So that's a lead time. How long do we deploy, right? Deployment frequency. There's change failure rates. There's mean time to recovery, MTTR, which means how long does it take for the team to recover from a failure or an incident. There's defect escape rate, how many bugs or defects get past the development environment and into production. The lower the number, the better. There's also customer ticket volume. How many tickets are we getting? How long is our system down for? Application performance. All of those things are very useful metrics. Yeah.
All right. Let me join back here and take that banner down. All right. It looks like that's it for the questions. So before I let everyone go, I want to let you know about a couple of offers we have. We have we have training content for all the major cloud platforms, like our GCP, Associate Cloud Engineer, for example. It's a boot camp that includes labs and one-on-one coaching. It's only $188. I'll drop the link in the chat there. Let me hit send on that. And then we also have an even better option if you're interested in learning more than just one skill. We have our monthly subscription for annual coaching, or for coaching rather, that you get access to all of our training and labs at no additional cost. Coaching starts at just $64 a month. So that's the way to go if you're serious about advancing your cloud career. So Zaki, before I let everyone go, any final thoughts?
I would say coaching is really important. Like coaches, our cloud coaches, coaching is what got me through my own cloud automation journey. Back then, we didn't have a lot of details and all this helpful information today. ChatGPT can only give you so much, guys. It won't give you insights. So that will come from a real human still. So, definitely leverage a cloud coach when you can for your learning, for your deployments, and so on.
That is a great point. And please send me a message if you'd like to be notified of upcoming events, so we can add you to our list. I know Zaki is going to be coming back and hosting a few trainings over the next couple of months, so stay tuned for that. However, our next training is July 12th at noon. It's running generative AI and LLM on a Kubernetes cluster. So that'll be fun as we
Wow.
get into, some containers and Kubernetes and AI, which is obviously a hot topic as well. So hope you can join us for that. Zachy, thank you so much. Appreciate your time. And
Awesome.
we'll see you all next time.
Bye, everyone.